Hi, everyone. Well, I'm really excited to be here. Like, I may be biased. I don't think I am, but I think I got the best moderating panel of the whole event here at Redefine. So, really excited to have you here, Sreeram. EigenLayer is such a hot topic in the market. I'm gonna pepper you with questions over the next 30 minutes. So let's get into it. But can you just, to start off, can you just give us a quick background on why you just started, why you wanted to start and build EigenLayer as founder and CEO? And let's do that, and let's dig in deeper.
Yeah, absolutely. My pleasure, Andrew, to be here. Um, we started Eigen Labs nearly 3 years back. Before that, I was a professor at the University of Washington, Seattle, running the University of Washington Blockchain Research Lab. I've been interested in the blockchain space for since 2017 and working on scaling consensus protocols, the infrastructure layer. So you can think of EigenLayer as a platform to enable more innovation at the infrastructure layer of crypto. So that's why it was a kind of a natural transition from trying to be an innovator at the infra layer to actually creating a platform to enable innovation there.
Yeah, sure. Then maybe quickly, like you could talk us through your logic on how did you decide that this is the idea, this is the business? Because, like you've said, you've got a heavy research professor, tier one university background. You must have cycled through many ideas. How did you go, this is the one, I'm building EigenLayer?
Yeah, they say like, the best product is one for which you are the customer. And the first time we built, 5 years back or more, actually 6 years back now, we s- we were like, hey, we started with we have good ideas for how to build like blockchain consensus protocols and scaling and all of this stuff. And the initial thing as an academic was you try to get it used. Let's go to Bitcoin, let's go to Ethereum, let's see
Yeah,
like who can actually use this. And then we realized both these protocols have gone through their own opinionated evolution, but also they move very slowly for good reason, right? Because they're big, like ocean liners that you don't want to do rapid movements. On the other side, um, and so after that, we are like, okay, maybe that seems like the only thing you can do is to start your own blockchain. It seems like that's
mm,
the only thing you can do if you're building at the infra layer. And I said, okay, like maybe that's what we have to do. And this was 2018, 2019. And we said, okay, let's just build our own blockchain. And we started doing that. And then we had no idea what like a blockchain developer is using or is looking for. We said, hey, blockchains need to be scalable, otherwise it's not going to work. Let's just
yeah,
build a scalable blockchain. So, and we said let's not write a white paper, let's just build it.
yeah.
So we built a project, it was called Trifecta at that time. Trifecta for solving the blockchain trilemma. And I said, okay, now we have a product. Let's go and like, try to raise money. It's 2019,
Yeah.
bear market. And we go and try to raise money. And everybody asks me, Srinam, you're saying you can do 100,000 transactions per second. Do you know what people are going to do with it? And this is 2019, and people were like losing faith whether like Ethereum will have
Yeah.
fill the block space or not. And I said, I don't know what developers do, but eventually, if blockchain's a thing, you need scale, and this is what we're building for. And thankfully, it didn't get funded. We didn't go ahead with that
But it's a good
project.
company name, like Trifecta. I like the company name, by the way. Like, yeah, yeah,
Thank you.
yeah, yeah.
Thank you. So we then moved on from that, and I've been looking at what the right thing to do is. Then I found it's not just me that is blocked by, when you have an innovation, I think, civilization thrives on specialization.
Mm,
Like somebody who's an expert at infra should just do infra. They should
yeah,
not also do an NFT and an ecosystem and like, let's create a community. Just too complicated, right? Like a person who's great at building a community, they should build a community. The person who's great at building like, hardcore distributed system infra, they should just build distributed systems infra.
Yeah.
And so I found this to be the most kind of missing piece in the blockchain stack is somebody cannot just do that, right? Like somebody
Mm.
has a great idea how to build a distributed system. They can't just do that. They have to do everything else in building a layer one. Build a token of value, build a community of holders, build a community of stakers, build a community of applications. It's just too many things that you
Yeah.
need to do. And so, kind of inspired by the cloud era, I said, oh, look at the cloud. Like, in cloud, if you're a good developer, wherever you are in the world, you can just write a good application and then send it to the cloud and it runs there. So very low kind of barrier to entry. And that is true, actually much better in smart contracts because
Yeah.
you can write a smart contract and deploy it on top of Ethereum. You don't unlike in the cloud, nobody needs to even trust you that you're actually doing the right thing because the blockchain is providing the trust and you're just writing the code. So it's actually way better. Like smart contract, the level of permissionless innovation in smart contract is much higher than Web 2. The level of permissionless innovation in like the core infrastructure layer is much worse than Web 2. Like this was the discrepancy that we were observing. And so the goal of EigenLayer, Eigen in German for your own, right? Build your own layer. Anybody should be able to build their own layer. EigenLayer was designed as a mechanism to, or envisioned as a mechanism to allow more permissionless innovation. So that was in the infrastructure layer. So anybody who has an idea for, hey, I want to build a new Oracle, I want to build a data storage protocol, I want to build a new chain, I want to build a new AI protocol, I want to build a new two-factor authentication, decentralized manner. Anything that you could come up with, you should just be able to write the code and send it to the network. The network should manage the group of validators. It should manage the group of stake where people are putting down money to promise that they're running the services correctly. So you know that they're going to do the right job. So that's the vision for
Yeah.
EigenLayer. It didn't start off as a staking project at all. And in fact, I should say that we came up with the name EigenLayer and permissionless innovation way before we had the idea of restaking. So I should say restaking is a kind of like a step to get us towards the goal. The goal is, and as this panel's or Fireside is titled correctly, permissionless innovation is the
Got
goal.
it. All right, let's dig in. Well, the next thing, and thanks for the background. Sounds like you kind of can moonlight as a serious marketeer as well with the branding elements that you get right. And I might as well just say it now. I'm going to go copy with pride on your Zoom background as well. I want one of those. I'll do a Blockdaemon version later. I'll ask my marketing. But I think there's a couple of topics I think the audience want to hear from you. And this concept of shared security, like it's moving around the market. Can you just talk to us about how you've come up with this concept of shared security and how you have, with the recent launch and continue to plan to implement shared security specifically on Ethereum with EigenLayer? Yeah,
Yeah.
that'd be a good one.
Yeah, absolutely. I think for the people who are deep into, or at least like have seen the landscape of blockchain, this idea has been around, right? Like the idea of sharing a common security pool has been around. And you can say Ethereum was the first protocol for shared security because
Yeah,
every app, before Ethereum, every application had to have its own security.
yeah,
So if you build Bitcoin, Bitcoin's application specific, right? So you're basically just building for that one application, which is peer-to-peer currency or like a store of value or whatever the version is. But if you wanted to build an application for domain name system or a storage or anything else, you have to build your own like security for it. And what Ethereum did is it said, hey, let's just have a common like protocol and make it universally programmable. So anybody can write any program on top of it. So this was the first, in my view, like successful attempt in shared security. There were other attempts in, for example, Bitcoin merged mining was
mm,
basically one other idea, which was saying, hey, you're already expending this mining power in mining Bitcoin. Can I somehow use the same mining power to also mine some other coins, right? Like, so that was the idea of merge mining. And but the Ethereum's like shared security was much more powerful. the idea was that, hey, I have like this common smart contract platform. Anybody can write these programs. Each program is an application, and then these applications can work with each other. So all those elements together made the Ethereum shared security system. So if you look at Ethereum, and Cosmos was the
Mm,
other major like ecosystem, and Cosmos said, let's Ethereum said, let's fix that we want to give shared security and try to see like how much innovation you can do, like how much smart contract programmability we can do. Cosmos started at the other end. It said, I'm going to make it total open innovation. I can change anything in the stack. I can write the code. I can write the consensus. I can change the peer-to-peer network, do whatever, but I'm giving you a stack. So
mm,
no shared security, but extreme open innovation.
yeah.
So that's what like Cosmos started with. And then I would say Ethereum then moved to, um, oh, I can give you a little bit more open innovation by going to the rollup era. Rollup era is like now anybody can come and build a rollup. All the rollups share the common security by writing the data to Ethereum and submitting the proof that you did the execution of your computation correctly. That's the rollup era. I'd say Ethereum said double down on shared security, but try to get more open innovation. So that's
Mm,
the next step. And then
yeah.
on the other side, Cosmos said, we're going to do this interchain security, ICS. ICS was, um, okay, I'm going to have the Cosmos Hub, and every validator in the Cosmos Hub now needs to run the few other protocols that we are sharing security to. So this was the kind of like the next evolution. I think where we came in, we said, what is the most flexible form of shared security and open innovation, where you can share as much security as the nodes are comfortable sharing, and as much innovation, I can innovate at any layer I want, but also partake in whatever amount of shared security I can obtain in the free market. So the idea was basically when you stake in a protocol, you're basically making a promise that you're running that protocol correctly. What EigenLayer does is it says when you're staking and saying, promising that you're going to run Ethereum correctly, you're also promised that you run, a data storage protocol correctly, or a AI protocol correctly, or whatever other protocols correctly. So you can think of EigenLayer as generalized programmable staking. When you're staking, you're making promises, not just one promise that you're running Ethereum correctly, but you're running all these protocols correctly. So that's a kind of like expansion of the innovation economy. And how much shared security do you have? You have how much of a shared security as nodes are opting into. So it's a free market of shared security. It could happen that everybody runs everything. It could happen that every application has its own validator set. So just
Yeah.
make it a market structure rather than constrain it. So that's the core idea of the EigenLayer shared security ecosystem.
Yeah, I think you said a couple of things in there really interesting. I like it, the opt-in modularity and the promise. And like I think, the way you've explained it, with Cosmos and Ethereum, I think that makes a lot of sense. I've definitely personally seen things bouncing around on Twitter on this, but that was really clear. So thanks for that. All right, the next one, it's, and it always comes up, right, is incentives. So, we'd love to talk to you about this. Where are you currently at with EigenLayer, and how do you see like the incentive mechanisms working now, and how do you think that may evolve, as you step forward into the future as well?
Yeah, the current uh, the current incentive mechanism is, so firstly, right now on mainnet, what do we have? We have stakers, people who can stake, and there are two kinds of stakers. You can stake natively on Ethereum and then set some, you know, uh, give some withdrawal powers to the EigenLayer contract, or you can take an LST and stake it on EigenLayer. So these are the two kind of major mechanisms. The So that's staking. Operators. So stakers can delegate to operators who run the services. So that's also on like mainnet. And then operators can select AVSs. AVS is actively validated service, a service
Yeah.
that you run on top of the EigenLayer shared security ecosystem. And so you can take an AVS, and AVSs can come up and say, here is the AVS contracts, here is the code. Can you go and run it? And then operators can decide which ones they want to actually participate in and run it. So that's the third one, which is AVSs. And one AVS that we have ourselves built is called EigenDA. That's also on the mainnet.
Yeah.
And so all of these are right now on mainnet. What is not yet deployed on mainnet is the payment mechanism. So
Yeah.
AVSs cannot pay stakers and operators yet. So the payment mechanism is not yet deployed. The second one is the slashing mechanism, which is
Mm.
when an operator misbehaves, what is the slashing condition, and how do you slash the nodes for it? These two are not yet deployed on mainnet. And the reason is for payments, we want to observe a little bit of the market dynamic before we actually have payments enabled to understand what the market structure is. And as we saw, many of these like shared security models, I mentioned like Cosmos and Ethereum, but also you can look at Polkadot, you can look at other
Yeah.
ecosystems. The market mechanism is at the heart of the whole thing, which is where how the incentive flows, how the what are people paying for, and are they incentivized to do it? Is it overpricing? Is it underpricing? Is it pricing the right dimension? All of this stuff. And I think this is much more complex than people anticipate or that to be. So, and rightly, some people are like, oh, EigenLayer doesn't have payments yet. And it's because it is not it may be easy to implement, but it is not an easy thing to get right. So we
Yeah.
understand that we're kind of like observing the market dynamics a bit in this thing. So our estimate is in like, 2 to 3 months, we'll have payments on mainnet. And right after that, a few months after that, we'll have the full slashing. The interesting thing with slashing is the slashing code was already on the mainnet from day one. We just haven't turned it on because we
Yeah.
know it's has to be done very carefully with all kinds of checks and balances. So that's just what we're doing on the slashing side. The In terms of the different sides, the stakers, they're opting into AVSs because they're getting, fees, right? So, or they will be getting fees when payments live. And the operators, they're helping serve and they'll get a portion of the fees. And one of the things we're thinking about is how to make sure that there are correct incentives for pricing all the different sides, right? For example, several people are worried that, oh, if we have 15 billion plus of shared security right now, how is, who needs 15 billion of stake and who's going to pay like, the kind of fees for this? And when you think of, oh, it's just a 15 billion pool, it seems like a lot. But each application may have a demand for a portion of this pool. And so there should be a mechanism to quantify that portion that you want and then pay for it. And it should be incentive compatible for people to quantify it correctly and pay for it.
Yeah.
So this portion we call attributable security, which basically
Mm.
says there is a portion of shared security which, if slashing happens, you just burn the funds. But there's another portion which is specifically redistributed to the AVS. And this redistributed thing is called attributable security, and you have to pay more to get more attribution. So this creates a dynamic where, if you're Base or Coinbase or whatever, like a major player, you have an incentive to get an attributable security proportional to your actual kind of demand,
Mm.
whereas smaller players will take lesser portions of shared security. So that's the kind of mechanism there. And the
Yeah.
second one is operators need to get paid for the amount of computation, not the amount of security.
Mm.
And so there should be a separate dimension of payment, which is for computation, not for the amount of stake. And so this is the thing that even inside payments will have a phased roadmap where we face each of these things, one after the other.
Yeah. Yeah. Thanks for the answer. I think, obviously Blockdaemon is one of EigenLayer's launch partners, and we're really excited. And what we've noticed is there's on the institutional side two types of customers. Both of them are excited about EigenLayer, and there's some that are like, you know what, I'm just going to go. Well, there's trust. They know it will work out. And why I think the 15 billion is not that big of a number is, we've got a bunch of institutions a little bit more traditional and conservative, right? Who are saying, yeah, look, I like to look at EigenLayer, like I like what it's doing, but for a variety of compliance reasons, I can't participate until a few more things are laid out. So like I think, just from a personal perspective and what I can see in the market, there's still a lot more opportunity there. And then obviously, as you said, that extra dimension is the AVSs, right? And I think, correct me if I'm wrong, you're at about 10 now. I know at Blockdaemon we're looking at 5 or 6, but like, yeah, I'd love to understand how you keep up with that, right? Because on the operator side of this, it's, not trivial.
Yeah.
But maybe we could jump back to the first ABS, EigenDA. Maybe why don't we start there and let's get into the data availability layer, and then let's just talk the folks through it because there's just a lot to unpack here, Sreeram. Yeah.
Yeah, totally. So the EigenDA is designed to complement Ethereum's layer 2 scaling roadmap. And one of the ways we think about it is what the layer 2 landscape is doing is basically creating the roadmap for the following kind of architecture, where when you're running a rollup, you're basically think of it as like, I'm running a web server, but I'm going to make this server provable to Ethereum. Like that's what you're doing. You're basically like making that connection. But normally, when you're proving that you're doing the computation correctly, other people should have an ability to download and access the input and output data so that they can verify that you're doing it correctly. And so that's what a data availability layer does. So it's a place for publishing data, which is very secure, because if that layer says that your data has been published, it should be published and accessible, because if it's not accessible, then nobody else can download and check that you're doing the right thing. Okay, so that layer, EigenDA, is so that we call it EigenDA, EigenData availability. And the main thing we optimized for is the scaling the Ethereum data system. And instead of Ethereum's data throughput being, tens of kilobytes per second, EigenDA is starting at 10 megabytes per second. And we have a very aggressive scaling roadmap where we want to get to hundreds of megabytes per second and maybe even gigabytes per second in the coming years. So that's the in our view, the core bottleneck for the entire layer 2 scaling roadmap is data availability, because once you have a highly scalable data system, then you can put a lot of data on it, and then now the scope of what applications can be built in crypto just expands.
Yeah.
So that's the kind of core thing. We've done a lot of economics and pricing carefully there. For example, you can reserve an amount of data throughput as a rollup instead of having to deal with each time you're bidding, each block you're bidding for block space. Instead of that, you have like this long-term reservation. Like, you have a portion of data, nobody else can compete with you there. You can just keep writing. So a new NFT comes in and then you get drowned. This kind of thing cannot happen. So that's one. So we've innovated a lot outside of the particular scalability, but that's the first service, EigenDA,
Yeah.
that we.
Let's dig into that because it just, reminds me of a couple of AWS analogs, EC2 reserved instance, EDP. And a lot of customers would say, I love the flexibility AWS, but I need consistent pricing and I need consistency, and I value that. So like I imagine that there's a lot of larger, maybe, institutional, more traditional enterprises that are, quite excited about this because, a lot of, large institutions don't like dynamic and inconsistent pricing because, how complicated it makes their business. So that sounds really exciting. Like, is there any specific feedback from customers or partners that you're hearing on this feature that you can share?
Yeah, right now, the thing is, even the tens of kilobytes per second that Ethereum has unleashed with the new like 4844 upgrade is not being like fully used. So that's the scenario that we are in,
Yeah.
which means basically that, and one of the reason is rollups optimized a lot for writing less data. This is the kind of
Yeah.
like history, because it was very, very expensive. So do compression, minimize the signatures. Like there's just a lot of engineering that went into that. And then now suddenly we're coming here and saying, oh, you're going to get 10 megabytes per second. it needs new stacks to come in,
Yeah.
which are designed not for a constrained data environment, but for an abundant data environment. So that's the next phase that we're seeing now. Few stacks coming up. We have which are building like brand new things based on this open like premise. Like Mega ETH is an example, which is building a high throughput EVM. Like other movement is building a move virtual machine. We have Versitas, which is building just take your like node.js software that you used to run on the cloud and just plonk it on top of EigenDA. So this kind of thing is going to start unleashing your like creativity a lot. But there is this phase where roll-up
Yeah.
stacks have to catch up
Yeah.
to, okay, now we have a lot of data. Now what do you do with it?
Yeah, and look, I'm an infrastructure guy. We always have an infrastructure innovation, and then we just say, okay, developers, let's see what you can do. Look, we're nowhere near the questions. We could go on much longer. I'm getting the hurry up nudge. Let's quickly do like actively validated services, AVS, right? If you could just talk us about, the architecture, kind of what's
Yeah,
available now, that ecosystem, that's really an important topic if we can quickly get that in and the
yeah,
moderator's not going to
absolutely.
cut us off.
The brief 1 minute summary is an actively validated service is think of it like, you know, anything that requires decentralized validators, right? So you need a group of validators, they all need to come to agreement, and then because you have enough of them come to agreement, you can trust it. Whether that is bringing data from the internet, like bringing like an Oracle, a bridge, which is moving data from one chain to another chain, like a data storage service. I want to store data in a place, but it's decentralized. So basically anything we build in the blockchain space, as far as I know, can be expressed as an AVS, an actively validated service. And the one thing we are building for is this model where I built an application, and an application today it needs either I go and build on a big chain, right? Like, Solana, or I built my own app chain like Cosmos. And the model we are building for is different from both of these. It's
Yeah.
like how you build an internet service. You build an application by concatenating a whole bunch of existing software as a service layers that exist on the internet. And then you say, oh, I'm using these things. And then, but these don't serve certain things. So I'm going to add my own code and then let it run on the cloud. And that's the same thing we are envisioning is somebody building a new crypto application will come in and say, I'm using this AVS for Oracle, that for data storage, this for data availability, that for AI inference. But I need to also do ABCD, and then I build my own portion and concatenate these things. This is the
Got it.
vision that we're building for, which can massively increase the scope of crypto applications from where we are today to something much larger.
Got it. Could I draw an analogy loosely to like a microservices Web 2 architecture? Like,
Absolutely.
okay, awesome. Got it. Well, look, hey, Sriram, like we only made it halfway through the questions, mate. Considering like how exciting it is for what you guys are building, I think that's not a bad effort. Maybe we'll have to do a follow-up session for the audience another time. But just want to, thank you for your time. And yeah, the whole market and ecosystem is really excited for, what EigenLayer is building.
Thank you so much, Andrew. We've been, it was such a great chat, and also we've been such grateful partners with Blockdaemon and looking forward to continue this.
Same. Thanks again. See you soon. Yeah, bye.
Okay.